Hi students, welcome to the physics class. Today in this video lecture, we will discuss electric field intensity due to a uniformly charged spherical shell. It may be a conducting solid spherical shell or a conducting hollow shell. So electric field for all these cases is same. We will derive one by one the field outside the shell, inside the shell or on the surface of the shell. So now we have given here the positive charge to the shell and we want to find electric field at P point, and positive charge is here, so the direction of electric field due to this positive Q charge will be outward side. So we will draw here the direction of electric field outward side, and r cap is the unit vector of the electric field. So to find the electric field at P point, we will draw a Gaussian surface of radius r, that is imaginary surface, and on the Gaussian surface at every point the electric field is same. So we are drawing here Gaussian surface, and let the radius of this Gaussian surface is small r. So this is the Gaussian surface. Now we have to find the electric field at this point, P point. So we'll take a very small area element of this Gaussian surface. Let the surface of this element is ds, and let n cap is the area vector of the ds element. So now we have to find the electric field, and we will apply here the Gauss law, and the radius of this imaginary Gaussian surface is r. So according to the Gauss law, we will apply here Gauss law. According to Gauss law, we can write the line integral of closed surface, that is E dot ds is equal to q by epsilon naught, the charge inside the equation. We can write q by 4 pi epsilon naught r square is equal to E. So here we can substitute the value of E vector and ds vector. So E vector you can write equal to E r cap, and ds vector you can write n cap ds, that is equal to q by epsilon naught, and we know r dot n cap is equal to 1, and E is constant, electric field is constant, so we can take it outside and you will get this expression. And what is the integration of ds? This small surface is there and we want to find the flux due to whole surface, so we will integrate it. So what is the integration of ds surface? That will be equal to 4 pi, r is the radius of the Gaussian surface, and that is equal to q by epsilon naught. So here what will the electric field? Electric field will be equal to 1 by 4 pi epsilon naught q by r square. So which implies electric field inversely proportional to the square of the distance inside the, this is outside the shell. Now we will find for at a point on the surface of the shell. So second case is on the surface of the shell. On the surface, so we have this radius was your capital R. Now we will take P point on the surface of the shell. So you can write r is equal to capital R. So in that case your field will be maximum. You can replace small r with capital R in the previous equation. You can see here you have to replace r square with the small r square with the capital R square. Now we will write it in the different form. We will write this one in the term of surface charge density. So let, if sigma is the surface charge density on it, and Q is the total charge, so you can write sigma is equal to Q by 4 pi epsilon naught r square. And here which r square we will take, that is the r square of your surface radius. So here we will write r square, capital R square will write here, Q by 4 pi r square, and from here you can find the value of Q, that is equal to sigma 4 pi r square. Now substitute this value here, you will get electric field expression in different form, sigma 4 pi r square and 4 pi epsilon naught r square. R square cancel, 4 pi cancel. So finally you will get electric field on the surface of the spherical shell in terms of surface charge density sigma by epsilon naught. Now in the next case we will find the field inside the shell. So inside the shell r is less than r. So earlier you have taken a sphere having radius r. Now you want to find the field at P point, that is inside the shell, and the r is the distance of P point from the center. So you can write r is less than r. So now according to the Gaussian surface, according to the Gauss law. So according to Gauss law or Gauss theorem, you can write electric field E dot ds equal to Q by epsilon naught. Okay, but for conductor Q is 0 inside the conductor. So if Q is 0, overall what will happen, your electric field will be equal to 0. So it means inside the conductor there is no electric field. So now we will draw the graph for these three situations. First one, when the charge is inside the solid sphere and you have to find the electric field inside, then outside, and third case is your at the maximum case. So how will you draw? You will take one side the r distance and the other side electric field, and here this is your origin. So we know inside the sphere, inside the conducting shell, the electric field is 0. So distance is going to increase or decrease, but electric field will be 0. So at this portion electric field will be 0 inside a, or you can draw here a sphere. So inside it the electric field will be 0. Where it will be maximum? At some distance it will be maximum when your r is equal to capital R. So we'll draw a straight line here where the field will be maximum, and after that outside the sphere, if you take any point outside the sphere, so electric field will be decreasing. We already derived outside the sphere electric field will decrease like that. So this peak is for maximum case, and this exponentially decays for the electric field outside the spherical conducting sphere. So this graph is important. In the next lecture we will discuss electric field due to a infinite long plane sheet. Till then, take care and thank you for watching.